This chapter presents concepts related to software, concepts that managers should understand. Software is basically the instructions telling the hardware what to do. We'll talk about different types of software, and we'll also present this layer cake model that exemplifies how different layers of software interact with one another in order to talk to the hardware so that you can get something accomplished. Retrieve data, send data to the cloud, send an email, that type of thing. You can get a general appreciation of what software is by thinking of it as a multi-tiered layer cake. So at the bottom of this cake is the hardware that is actually doing something with the instructions that you are giving it. The operating system interacts very closely with the hardware, pulling data in and out of memory, writing to the drives, and reading from the very fast RAM memory. And then above the operating system is the actual application that you install. And the application is like Microsoft Office, and then Office interacts with, say, Microsoft Windows, the operating system that interacts with the hardware. And then at the top of the layer cake is you, the user, that is interacting with the application that you've installed that interacts with the operating system that tells the hardware what to do. We've discussed hardware in previous chapters, so let's discuss operating systems that interact with the hardware. An operating system is like Microsoft Windows or Mac OS X or Linux or Unix. IBM has operating systems also. They provide the platform from which applications can be developed. So you develop applications for a platform, compiled for a platform. So this is like the network effects that we discussed in the last chapter, where if you have a good platform, you can create more applications that draw more people, that draw more applications. Here we see the effect of network effects with operating systems in that Microsoft has a monopoly basically in desktop operating systems. And in server operating systems, Linux and Unix being free and doing what they do very well, Microsoft has had a little bit tougher time getting a monopoly there. And in the mobile operating system and tablet operating systems, Apple has done better because of this idea of network effects and being first to market. Going up the tiers or layers of the layer cake model, let's look at application software. There are different types of categories of software. There's desktop software, which is meant to be used for a personal computer, like your browser or Microsoft Office. There's also software like utility software for managing your computer, transferring files and getting rid of viruses, things like that. But what we want to focus on is this type of software called enterprise application software. And it's going to consist of enterprise resource planning, supply chain management, customer resource management, and business intelligence. Enterprise resource planning software, or ERP, is a module or software package that can be part of a suite of software packages that deals mainly with the internal operations of an organization. So they're dealing with the functional areas at the different levels of an organization. And they want to integrate all these together, and these enterprise applications usually sit on a database. So you can have enterprise resource planning software that deals with manufacturing or human resources or purchasing or tracking or sales or decision support, these types of things. Other enterprise applications besides ERP are customer relationship management, which gives a unified face to the customer and manages all the marketing and sales activities, supply chain management dealing with logistics, and business intelligence systems that tend to look at everything that's going on and look for trends and ideas and possibilities and maybe inefficiencies. All of these enterprise applications usually work with a single database. There can be more than one database, but that can lead to some problems with data sharing and redundancy. So all these enterprise applications work with a database, and then that database is going to have firewalls and filters that will let the sharing of information be such that only the proper information is shared with the proper people. So you can share data with your partners or with your customers, but you don't share all the data. Enterprise applications are very powerful, but it requires a tight integration with your business processes for it to be useful and a good return on investment. So you can spend a lot of money on enterprise applications and you don't achieve your goal. You have a failed project, and there can be various reasons for that we'll discuss towards the end of this. But there are examples here, and another example is Kmart that tried to mimic Walmart's supply chain management capabilities. We are in the era of computing where computers talk to one another quite a bit. And what this creates is a model that is known as a multi-tiered distributed client-server system. So you can think of it as you are the client and you are requesting things from a server, kind of like a customer requesting items on the menu from a waiter. So we have these tiers of processing, and that's why it's a distributed processing environment, and different activities are occurring at different layers or levels of this multi-tiered system. At the application layer or app server layer of this multi-tiered system, there are these little programs called web services that might return a calculation or access a database to get some results. And you can create these little applications or little bits of programming called web services and combine them into a service-oriented architecture that allows companies to do pretty fancy things like Southwest did by creating a service-oriented architecture that brings together rental cars and hotels and airline booking all on one website. The fastest software is written for a particular operating system and hardware, and it is written and compiled to be run, that's the executable, on that hardware platform. In order to write software, you usually do this within an integrated development environment or IDE, such as Microsoft Visual Studio. An alternative to a compiled program that creates an executable to be run on a piece of hardware is an interpreted language like Java that is an example of this write once, run many. An interpreted language is interpreted line by line at run time, and that has some advantages. The advantage of Java is that you can write software once and run it on many different platforms as long as you have the Java virtual machine for that platform. Here's an example of a GUI that I created using Visual Studio for C and C# last fall, and it's for an optimization software program that I wrote for some research that I was doing. As a manager, when you are involved with projects that deal with enterprise applications or big software programs or infrastructure development, there are some items you need to think about. One is the total cost of ownership that can involve compliance and backup and disaster recovery and distributed denial of service attacks. And the other is understanding that some projects fail. In fact, projects fail or don't meet requirements relatively often. Why do projects fail? Well, there can be many reasons, and it's not just one reason typically. Some of them are that the requirements were not understood, and so you didn't implement them correctly, and then they weren't tested properly, things like this, poor project management. But luckily, if you keep track of these things and you mature, you will determine ways to deal with these problems as they occur. Keeping track of your best practices can help you manage and prevent problems so that you can have successful projects.